Hey, what's up, Franklin West? I have another video for you today to help you with combining like terms in your algebra unit. So the video will spend some time talking about the vocabulary involved in doing some of this work and walk you through how to identify like terms, consolidate them, and then at the end, there's a little extra as bonus in terms of how a problem can grow its direction or ask of you based on additional information that's provided. So I hope you enjoy the video. All right, here we are. We're ready to jump into combining like terms. I want to first start with acknowledging that math is really its own language. And that was one of the things that was always tricky for me when I was learning it, is understanding what all these words mean. So I just want to take a quick moment at the start of this video to talk about what it means to be using the word term. So a term is any position of value within an equation or expression. And so we have a 4, we have a 3a, and we have a negative 2a. We have a total of 3 terms in this expression. I'm using the word expression versus equation, and here's why. Because we have all these terms together, but they're not set equal to something. There's no equal sign. And so we call these collection of terms without an equal sign an expression. And the moment an equal sign shows up, we call it an equation. So they're almost synonymous, just a small nuance there. So now that we've identified we have 1, 2, 3 terms in this expression, let's double check if we understand what it means to be a like term. Because if you are a like term, you get to combine them. It's like having one pile of apples over here and another pile of apples over here. Let's make them one pile of apples. Okay, so we have a 4. A 4 in this case is just called a constant. There's no variable letter with that 4. And as we give us a quick scan, there's no other term that also is just a number. So 4 does not have any like terms, and so it will continue to exist in the next line of work that we create. But when we take a look here, we have a positive 3a, and always remember the sign in front belongs, and we have a negative 2a. They both are a as the variable, and not only that, but there's no number up high, no exponent, and so these are exactly alike. So 3a and negative 2a are combinable, and so you get to just put a little thought bubble over here and think of, what is 3 subtract 2? Okay, well, we know that equals 1, and therefore we have 1a. And because that was a positive number right there, 3 subtract 2 is a positive one, we get to write 4 plus a. I could have written 4 plus 1a. Both would have been correct. Okay, so this is the thinking we're doing here. So I bet these others will go much faster. As we go over here, we're going to scan for all the terms. We have a total of 3, and we're 5x and then a negative 8x. Those are like terms. This positive 3y is kind of on an island by itself compared to those two. And so now we just want to combine who is alike. Now keep in mind that's 5x, but that's a negative 8x that we're combining it with. So that should feel like 5 subtract 8. Don't say it's 5 plus 8. See how I made the cursor jump 5 and then plus sign? That plus sign does not belong to the 5x. So the next sign after 5x will come from the number you're combining it with. So because that 8 has a negative sign in front of it, a subtraction sign, that's a negative 8x. And so it's actually a 5 minus 8 operation that we're going to do with the coefficients there. So 5 subtract 8 is negative 3, and that was for the x term. Don't ever lose the variable. So common in student work as they learn. So if you know that now to watch out for it, maybe you won't fall into that trap. And then the 3y we said had nothing to combine with it, and so it was positive, so it comes down as a positive 3y. All right, let's jump over. I guess I already worked in purple. Let's go to green. We're going to come over to the right-hand side. It's pretty much the same format, but what happens now that you have more terms? Well, you just scan the whole thing. You might have more than 2 terms to combine. So we are going to scan, and I see an x term here, another x term, and another x term. All of those are positive. It's a positive 5, positive 3, positive 8. So we're just adding all that together. So 5 plus 3 is 8, plus another 8 should get us 16 x's, all in one batch. And then that negative 4y had nothing to combine with it. So it just persists in the next line. And then that's our answer. And as you notice here, in combining like terms, it doesn't often yield you an answer that's one number or one term. Sometimes our answer in algebra is 2 terms or more. And because they were not combinable, they stayed separate. So let's take a look at this last one. We have a 14. That's a constant. We scan through. We have a negative 7. That also is a constant. So they can come together as 14 subtract 7 gives us 7. Now we have the chance for another combination of terms, of like terms. We have a positive 3y and a positive y. Remember, hiding in there is a positive 1y. So don't just write plus 3y. I see students do that often. This is 3 plus 1. So, and I guess I'll leave that color coded so you can see how it matches. This becomes 7 plus 4y. Okay, so that's the result of combining like terms. I'm just going to go one step forward briefly and suggest that, well, what if we actually knew the values of these variables, right? What could we do then? Well, from there, we could substitute those values in for the variables and then evaluate. So 2 more math terms there, substitute and evaluate. Okay, so let's say in this example that we're going to continue forward, let's say that x equals 1, and we'll say that y equals negative 2. Okay, so let's practice a substitution and evaluation. This often happens after a combining like terms step. So we've combined like terms. We'll just focus on these 3, not the top purple example. And let's see what happens when we say x is 1 and y is negative 2. So we're just going to substitute in. I have a negative 3. That's this negative 3 here. And I'm going to always substitute using parentheses. And this problem told me that x has a value of 1. And it also told me that y had a value of negative 2. And so now I'm in a place where I'm using order of operations, our PEMDAS. And so we are going to multiply at the parentheses, and then we're going to add those like terms, those constants. So negative 3 times 1 is negative 3, and 3 times negative 2 is negative 6. Notice I didn't write plus negative 6. I totally could have. I always try to work in a way where I don't have redundant signs. And so if I'm at negative 3 on the number line and I take away 6 more, I should be at negative 9. It's like you borrowed $3 from your best friend, you borrowed 6 more from them the next day, you're going to owe them $9. All right, sliding over here, if this x, we're going to say these all are part of the same family of values. So that is 16 times 1, because x is 1, minus 4 times y is negative 2. So I'm going to put negative 2 in parentheses. Continuing our process, 16 times 1 is 16. It's a negative 4, don't lose track of that, times a negative 2. Negative times a negative is positive. So I should have 16 plus 8, and that should equal 24. All right, now the last one here, 7 plus 4y. There's nothing to substitute. That 7 will come down all on its own. The 4 repeats itself also, and now the y is negative 2. So 4 times negative 2 is negative 8, and we're combining a 7 with that. I could have written 7 plus -8, but again, I should end up with the same math process, so I just avoid two signs next together if I can. So 7 subtract 8 should get us a -1. So from start to finish in a process like this, you would combine like terms, scan all the way through, see how many terms are alike, get them consolidated, and then you leave it at that, unless the problem tells you that we actually know the values of those variables, and then we are going to substitute and evaluate, which is what we did here in blue, replacing the variable with the value assigned to it, following order of operations, combining those like terms to one final number. So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people.